Some more notes on position, velocity, acceleration functions, and a definition of speed. Okay, speed is the absolute value of the velocity. In other words, velocity can be positive or negative. If I'm moving to the left, the velocity is negative. If I'm moving to the right, the velocity is positive. So either way, if I'm moving away from a point, so let me go back and look at our little position here. So if we look at this, our object is moving here. If it's moving away from zero, the velocity is positive. Or if it's moving to the right, the velocity is positive. If it's moving to the left, the velocity is negative. But either way, the speed is how fast you're moving away from a point. So if I started at zero and I'm moving to the right at a certain velocity, my distance between myself and the object is increasing at a certain rate, and that's the speed. Just as if I'm moving to the left, my velocity is negative, but the distance that is being accumulated between myself and the object is positive. So right here, my distance is negative 10, my distance is 10, I'm 10 away, I'm just to the left. So speed is actually how fast you're moving away from a point, irregardless of whether you're moving to the left or the right of the point. Okay, so the speed is the absolute value of velocity. Now, definition of acceleration. Well, how fast our velocity is changing is our acceleration. In other words, if you're driving down the freeway and you're going 40 miles per hour, and then in 10 seconds you're going 60 miles per hour, then your velocity went from 40 to 60 miles per hour in 10 seconds. So it'd be 20 miles per hour per 10 seconds. You can reduce that. So that would be your acceleration. In other words, the acceleration is the change in the velocity. And we define that. Acceleration is the derivative of the velocities. And if you graph the velocity, the slope of the velocity would be the acceleration. Same idea. So the acceleration is the derivative of the velocity with respect to time. If a body's velocity at time t is v of t, or which equals s ds dt, then, that should be then, sorry about that. Then the body's acceleration at time t is a of t is dv dt, that's the derivative of the velocity, or the second derivative of the position function. Now this is something that you want to note. Speed is increasing when the velocity and the acceleration have the same sign. Speed is decreasing when the velocity and acceleration have different signs. Now think about it. If you take a projectile and you fire it up into the sky, okay? Remember, the gravitational constant is always pulling it towards the Earth, and that's going to be minus 32 feet per second squared. That's the gravitational constant. In other words, there's a force that's pulling us. Force equals mass times acceleration. So whatever your mass is and the acceleration is the negative 32 feet per second, that's going to be pulling you towards the Earth. That's called gravity. So if we throw a particle up, it's going to have an initial velocity. So the velocity will be greater than zero, but the acceleration is going to be less than zero. So what's happening to that particle? Well, after you throw it, it's going the fastest speed as soon as you let it go. And as you throw it up, it starts to slow down, slow down, slow down. So the speed is actually decreasing because even though the velocity is positive, the acceleration is negative. Now, as it stops and starts to come down, then the velocity is, since it's going down, the velocity is negative. But the acceleration is still negative because that's a constant. Whether it's going up or down, the acceleration is negative 32 feet per second squared. So since the velocity and acceleration have the same signs, it starts to speed up. So if you throw it up, it slows down, and after it gets to this highest point, it starts coming down, it starts to speed up. So this is something you might want to note. Speed is increasing when the velocity and the acceleration have the same sign. Speed is decreasing when the velocity and acceleration have different signs. And we're going to look at an example, so this will kind of all tie together, I hope. Okay, so if you jot those things down, you use them as references when we start looking at an interesting example. But if you do have the position function, you have a lot of things you can find out about that particle's motion, whether it's vertical or horizontal.